In this lecture, we are going to see a few things about how to check the mesh quality in two different ways, and what is target meshing, like target quality and other things. Okay, for that I already have opened ANSYS workbench. I already loaded in the model that I have provided you in the resources tab. So already I double clicked on the model cell and I was able to open the ANSYS Mechanical. Fine. So here once I open ANSYS Mechanical, what I will be doing is I will be generating the mesh with the default settings, and I will say generate mesh. And once I generate the mesh, the first thing is you can go to the statistics, and if you expand the statistics, you will be able to see how many number of nodes and how many number of elements have been created. So here total 816 elements have been created, and total number of nodes like 4557 total number of nodes were created for this object through automatic meshing. So if you go for the quality option, you can check for different qualities here. One thing is if you go to this mesh metric and you select different options like element quality, aspect ratio, Jacobian ratio and other things, you can see what are all the qualities of each and every element. See, for example, if I have selected aspect ratio, here I will be able to see here this many number of elements are having an aspect ratio which is nearer to 1.11. Likewise, if I select here this all elements are having an aspect ratio which is nearer to 1.50, and if I select here, I will be able to see that these are the elements which are having an element aspect ratio which is very near to 1.75. Likewise, you click on the histogram chart, you will be able to see all the highlighted elements on the graphics window. Understand the aspect ratio, or whatever the mesh metric you select, you will be able to understand that particular thing. Let us say if I have selected the Jacobian, let us say if I go for the Jacobian ratio, see here, if I select this, so these are all the elements which are having a Jacobian ratio which are near to 0.7, somewhere between 0.65 and 0.7 we are having. So based on this, you can filter out elements, you can identify elements which are having a lot of deviation from the required values, and you can change the mesh with all the localized and globalized settings that I have previously shown. So one thing, you can view all these elements like this, or otherwise once you just switch off all these things by selecting none, and now you go to the display style. In the display style, instead of using geometry settings, you go and select whatever the mesh metric you want to see. Let us say if I want to watch aspect ratio, I will click here, and once I select the aspect ratio, see here you are able to get a contour plot in the graphics window showing all the elements and their aspect ratios. For example, let us say if I have any elements which are represented in this dark blue color, so here for all these elements we are having an aspect ratio of 1.1 to 1.27. So the range of value is between 1.1 and 1.2. Likewise, you can select any of the mesh metric and you will be able to see a contour plot regarding this. What I will do is I will just minimize it so that I will have a good looking view, and I can select the element quality and other things. The next thing we need to look at is what is known as the element quality, and if you come down here in the quality group, you will be able to see there is something called as error limits. Here you will have two algorithms. One is a standard mechanical algorithm and second one is the aggressive mechanical algorithm. So based on selecting this algorithm, so what it will do is it will specify an error limit for itself, and remember, this error limit value you cannot change. So based on the type of algorithm you select, it will change that. If you go for aggressive mechanical, it will have more strict error limits. If you go for standard mechanical, it will have somewhat relaxed error limits. So based on that, what the software will do is once we told the software to generate a mesh, it will generate a mesh. Then it will check the qualities, element qualities of all the elements present in that mesh and see whether they are below the error limit or not. If all of these elements are below the error limit, then it will show the generated mesh, or otherwise if some of the elements are above the error limit, what it will do anyway, by default the option is adaptive sizing on, so it will try to change the size and some settings, it will try to tweak some settings, and it will regenerate the entire mesh and will check whether all the elements are falling below the error limits or not. Likewise, it will do 1 or 2 times, and if it is able to generate a mesh with all the elements below the error limit, what it will do, it will give out the final mesh. Otherwise, what it will do, it will show an error called failed mesh, which we have previously seen in a lecture where we talked about hexahedral or hex dominant meshing. There we have seen that the software has shown some failed mesh. So there we have to change some settings and we have to tweak our settings so that again the measure will generate and again this entire process will be done. And one more thing, remember, once you have all the elements that are below the error limits, then the software will check for target quality, and this target quality limits you can change it manually. So as I told you, once all the elements that we have selected are below the error limit, then the software will try to get the element quality to the target quality level which we requested, which we can specify it manually here, and based on that, remember one thing, it might get, it might not get. We are just simply providing it so that if there is any possibility, automatically it will generate the elements with that target quality metric. Okay, so this, it can be set manually. For setting it manually, you need to learn a lot of theory. So whatever the default value of 0.05 target quality that has been provided, it is suitable for all the for all linear things. It is okay. It's not a big problem that you need to change. So I will also set this to aggressive mechanical by default. If you are doing linear structural analysis, don't need to worry about that. And whatever the warnings that are being shown previously, I told you now in the previous lectures that some error warnings are coming now, that are because of this error limits, and you don't need to worry about that much. So I think this is pretty much it. So whatever the basic options you require to create somewhat good mesh for analyzing linear structural problems is already done. So remember one thing is, especially in industry, we'll have separate meshing softwares like HyperMesh, Shansa and other sorts of softwares, and there will be some specific engineers who will be dedicated to performing meshing, because it requires a lot of patience, a lot of manual works. For our basic purpose, this automatic meshing is more than enough. But if you have more complicated objects, if you have more complicated features and other things, very big assembly and other things, there you have to do a lot of manual and as well as patient work. Okay, so with this I am going to conclude this section on meshing. Thank you.